Also work with legacy code, trying to kind of round up the sharp edges and try to make it more usable for a modern audience. And that means we spend also a lot of our time working on Fortran. So I've got a double slideshow this, it's going to take a while. So yeah, so Fortran it's been around for a very long time. It's almost certainly the oldest programming language that you'll actually come into contact with in reality. So its name is short for formula translator or words to that effect. And what Fortran is really good at is taking mathematical expressions and turning it into really fast and efficient code. So it's been declared a dead language basically every year for the last 30 years. It wasn't true then, it's not true now. And actually, it's had a bit of a resurgence in the last few years. It's currently ranked, I think, 10th on the TOB index, I think it's called that, of the most popular programming languages. And it's very widely used within the HPC space. I believe if you look at the Archer 2 machine up in Edinburgh, the overwhelming majority of code running on that is Fortran. Now, it has been facing a lot of competition by C++ lately, mostly because C++ has traditionally offered much better GPU support, so as we're moving everything over to GPU machines, and C++ has been sort of taken over, but that gap is also now closing in Fortran with OpenMP offloading, CUDA Fortran, these kind of things. So essentially, Fortran's not going anywhere. It's going to be around for quite a long time to come. So the problem with being such a long-lived language is that you do pick up some problems along the way. So it has failed to modernize in some aspects. So its type system is a bit weird. Its object-oriented features are a bit clunky, and it's completely lacking things like generics, standard containers, like the standard library that you might expect in any modern language. On top of that, a lot of the older Fortran you'll see out there does rely on a lot of constructs that are completely antithetical to modern best practices. So you will see goto in the wild, you'll see common blocks, which are basically global data sharing. Things like character names limited to non-descriptive, like variable names limited to like 6 character strings that are completely non-descriptive. All kinds of horrors like that. So much like C and C++, this kind of long baggage of like older version backward compatibility means that it's quite easy to shoot yourself in the foot. Now, I would personally argue that actually within research software, the biggest problem with Fortran isn't actually the language itself, it's more the environment in which it's being used. So much of the Fortran you'll see hasn't been written by software engineers who have been trained in these best practices, being written instead by PhD students and other researchers who are frequently working alone. They might not have proper code review structures in place, and they're always working at incredibly tight deadlines. So I've come across this term of publication-driven development, and that kind of describes basically the main problem of research software. Code is being written in order to produce a paper or a conference talk or something like that, and that is the main driving principle. So people are cutting corners, they're not writing docs or tests, what you can end up with is just incredibly brittle code. And even for people who get out of that trap and do try to write good code, there still are additional barriers within Fortran in particular. So there's not as many kind of training resources in Fortran as you might see in something like Python. The Fortran community is quite fragmented. It's harder to find your people in this space. And even when you can find a community, people tend not to agree as much on what best practices even are. So, yeah, the final issue that I see in Fortran is that the tooling infrastructure just isn't there compared to other languages. So if you're used to working in something like Python or JavaScript, there's a very well-developed tooling ecosystem that'll help support ongoing development, especially for like big projects. So things like testing frameworks, documentation generation, all these kind of things. These tools do exist for Fortran, but in many ways they are significantly lagging. the state of the art. Another problem is a lot of Fortran developers simply don't use these tools when they're available. A lot of it's quite old, really long-running projects that started before these kinds of things became more commonly used, and these teams still haven't adapted. In other cases, they're just looking at the tools that are available and just saying these aren't good enough, they don't actually fit our needs. So that means on top of all the aforementioned problems, Fortran programmers are often coding kind of without any guardrails. They don't have these tools to kind of keep the code in good condition as it progresses. So to tackle this issue, we have created Fortitude, a Fortran linter, and this is a static analysis tool that aims to find potential bugs and enforce a consistent coding style. So this is going beyond what you'll get from compiler warnings and getting more into the realm of kind of an opinionated evaluation of your code. So while a compiler will be totally happy for you to use implicit typing or to declare all your functions, outside of modules, all these sorts of things, it's all valid Fortran, compiler will say that's fine. Fortitude will instead step up and say, this is a bad idea, maybe don't do that. So because it is going into the realm of opinions about your code, you might not agree with all of the kind of linting rules in there, and that's fine. We do offer enough customizability that you can switch on and off whichever features of the linter that you want. We do try to conform to community standards where we can, insofar as any such thing exists. So what benefit do you get from actually using this? So I personally think a linter should just be considered as a standard tool for everybody's development workflow. So especially if you're in research and you're working alone, it is a partial substitute for code review. And if you're working in a team, then they're also very good for helping enforce consistency across all of your contributors. For something like Fortran, where even quite minor mistakes can lead to very hard to pin down segfaults and the like, it's really useful to kind of have something to flag up these issues early before they actually become problems, and it can save you a lot of time in the long run. And for me, what I think is a really underappreciated aspect of things like linters is that they're actually an interactive educational tool. So by flagging up issues in your code, they kind of teach you more about your language. They'll educate you about the pitfalls kind of as you're coding, and that will help you avoid these things in future as you continue to code. So given that there are already Fortran linters out there, well, what does this one bring to the table? So it's designed to be very similar to a very popular Python linter called Ruff. So if you're used to using that, its user interface will be immediately familiar. It's very easy to kind of get started in using it. We have quite a large collection of linting rules already in place, and we have expectations to more than double this, hopefully in the next couple of years. I think our parsing is really very good. If you try to use any of these open source linters, it's quite common to run into parsing errors. Whereas for ours, unless you're using C preprocessor, which does cause issues, and we are working on that right now, you have to really try to find like standard Fortran that will break our parser. As I said, it's very configurable. So if you're using FPM, like a Fortran package manager, then you can specify your configuration just right in your fpm.toml file, or you can use a dedicated toml file if you prefer. And the big one is Fortitude will do fixes for you automatically. So it might flag up thousands of warnings, and the majority of those need to be fixed in an instant. You just pass -- fix, and that's it, problem solved. And possibly the main thing that stands out is it is really incredibly fast compared to the other open source offerings out there. So for this table on the right, I tried running Fortitude against a subset of Fortran 90 files in a plasma physics code called GS2. I had to choose this subset in particular because some of the other linters couldn't handle just recursively linting all the files in a subdirectory. So this was kind of the closest I could get to try to compare them side by side. And yeah, so these first two here, Flint and Stylist, both of these required some extra configuration just to get working out of the box, which isn't needed. in Fortitude, and on running them, I found Flint. It can only lint one file at a time, so you have to do some fancy bash scripting to even get it to do a whole project. And then when it did, it also failed to parse one of my files. Stylist has a slightly awkward setup, but once you've got that going, actually it does give you really nice output. So apart from the kind of the speed difference, actually Stylus is pretty good. I had a lot of trouble installing CamFort and getting that running on the code, and I couldn't really get much out of the output. I think it was having a lot of parse errors on the code I was using it for. To be fair, CamFort is more than just a linter, it does other things, so this might not be a entirely fair comparison. And the bottom one, called iCode, I think this is mostly intended to be like an Eclipse IDE plugin, but you can use it from the command line. It has a lot of rules implemented, but it throws up a lot of false positives, and the output is near unreadable to a human. But if you look at the timing, we are anywhere from, 50 to 100 times faster than all of these. So it really is a significant difference. Right, and for that, I think I can hand over to Peter, who will show you Fortitude.
Try.
Yep. In action.
So, what do I want to do? So, first thing I want to do is show you how easy it is to install. So, go to our website, quick start, you can download it. So there's a couple of different ways of downloading it. So if you're used to Python, you can install it with like pip or UV. If you enjoy just executing shell scripts off the internet, which we all love, you can do that. People want this. I don't like this, but people want it, so we do that. Or if you go to the GitHub page and like the release, you can just download the binaries for whatever platform. I guess this script can work out what platform you're on. So if you're on a Mac or Windows or an ARM machine, it can work that out and give you the correct one. Whereas if you download it manually, you have to guess. So what do I want to do? So let's get a new shell. Is that readable?
Yeah.
Getting readable. So let's go to, I've got, can't read it. So I've got a bunch of projects installed because I need to like continually test the code in the parser. So I've got like 200 Fortran projects installed, which is like 40 million lines of code. And then, you can just regularly run it on that sort of stuff. So what I'm going to do is I'm going to make a new virtual environment, which I will remove the old one for fun. Make a new virtual environment, source that, UV, pip install Fortitude.
Dashland.
Oh yeah, bummer. We didn't.
Yeah, I wasn't able to get the name on PyPy quickly enough, which was really irritating.
It was like, that's a good name, Liam. We should call it that. Yes.
I did get it on crates.io, but somebody got in before I could get the Python compatibility kind of implemented. Somebody else stole that name from me.
So does anybody recognize any of these projects and have a favorite one they want to run it on?
GCA.
Which, sorry?
MITGCA.
MIDG, okay. So, so to run it out of the, how do I make it smaller? If I can spell Fortitude, so out of the box, you just run Fortitude check and it works. That's it, right? And so 26 files, it found 876 things, of which 474 it can just automatically fix for you. There's another 144 that might be unsafe to fix, so we don't, they potentially change the meaning of your code. So if you think they're fine, you can just add this flag and we'll fix them. So we can look through some of these things. So, well, first of all, syntax error, because this is requires a preprocessor, this type, and we don't know what that type should be, and B, we don't do preprocessing yet. That's on the roadmap. This next thing, implicit non-missing external. So this is a Fortran 2023 feature, 2018 feature, sorry. So it's quite new, it's 7 years old. So that means actually most compilers have actually implemented this thing, but most Fortran programmers don't know about this feature, right? And it is a useful thing. So already it's telling you something that maybe you didn't know, and you can learn and try that. It doesn't work on NV Fortran, that feature. So if you've got CUDA in your code, maybe you don't want that. Here's another one that it's complaining about. This subroutine is not in a module or a program. So that means we can have a look at the explanation for that. This is a super common one. There's probably, out of the 40 million lines of code, probably about half of them just have some trading white space on, which is like, so this is a style rule. This is a correctness rule. So obviously trading white space doesn't matter, but it's annoying perhaps. So maybe in your project, you just want to turn all the style ones off. You just want correctness warnings. And so you can do that. So if we run check, and then we can run statistics. We've got bash completion as well, so you can tab complete stuff. If we look at that, then we can look at how many of each warnings it finds. So there's 200 deprecated relational operators. If we want to know more about that, we can run the correct thing, Fortran explain, and then either the name of the rule or the short code. So that's mod 021. And then it gives you a shorter or a longer explanation depending on the particular rule. Telling you, what that rule is checking for, and also a reason for why we're checking for that rule, not just like this thing bad, although admittedly, maybe this is not much more than this thing bad. So that's out of the box. There are a bunch more options that we can do. So one thing is that we don't turn all the rules on by default out of the box. As Liam was saying, some of them are like more opinionated than others. Maybe they don't make sense for everybody to have some rules on, but they make sense for some people to have them on, right? So we also, because we're continuously adding rules, we don't want to we found that, we've stolen lots of stuff off Ruff, and they have this preview mode where they introduce a new rule, but put it into a preview. So you have to type in an additional flag to turn it on. That just means that they can get some community feedback on if this rule is working. And we've already found that useful. Some rules we've got out into a release in preview mode, and we've had some feedback. They're like, that needs another option, or it's missing this edge case, or perhaps it needs renaming. So if we want to turn absolutely everything on, we can select everything, and also we can turn preview on, and we'll just run statistics. And you can see how fast it is. Like, this is completing basically instantly on 26 files. Okay, that's maybe not too much, but it means that if you have it integrated into your IDE, this can check as you're typing. It's fast enough to not interrupt your workflow. So here we go. We've got 2,784 compared to 800 and something right before with everything on, and a few more things. So things like implicit real kind. So this rule is checking for, well, let's have a look what it says. Fortitude, explain, implicit. This doesn't tab complete, which is maybe slightly annoying. Implicit, I keep typing rule, implicit real kind. So this one is checking for real variables that don't have their kind explicitly specified. And then this one has a slightly longer explanation of why that might not be bad, why that might be bad. This is kind of a bit more of a pedantic rule, so we don't turn it on by default, but we anticipate that actually quite a lot of code bases would want to enforce this rule. And this has a reference, so you can kind of go read more about it. So we've talked about automatic fixes. So if I run all this and then just run dash dash fix. So it's fixed a bunch. There's some that it hasn't fixed. This will be because it's tried to apply the fix, and then discovered that it might have introduced like a syntax error. So then it bails, it doesn't apply that fix. So we quite strongly guarantee that we won't break your code too much. If we turn on unsafe fixes, then we're gonna fix a bunch more. And then if we look at git diff, we can kind of see the sorts of fixes. Here we've added type and external to implicit none. This is because, so if you know about Fortran, implicit none, it turns off implicit typing on variables, but doesn't turn it off on types or external functions. So you can still have implicitly defined external functions, which seems, why would you run that? Here we've got a lot more.
There's single quote strings to double quote strings. A new one that we've added.
Yeah, here we're changing old style greater than to the symbol, putting spaces in end if, things like this. We've got a whole bunch of changes. But there you go. So that's a real quick run through of getting started, some of the features. I was going to show. Does this have any pre-processed? Oh yeah, we've seen some pre-processed files. So if we look in, I want to just do it on one file. Yeah, that one, verification, HS 164 code. So if you want to check pre-processed files, here's a workaround that you can do. So you can pre-process it with your, it's all right, for G-Fortran E, pre-process it. So maybe you're also using things like FIP or PF unit or some custom preprocessor. You can run your preprocessor over the file and then pipe it into Fortitude, and then you can give it the file name. So cost test local.f90. And well, that's G-Fortran breaking immediately. If this worked, you would have seen Fortitude checking the pre-processed source and kind of giving you information about where it came from. So you can run this sort of stuff in CI and catch that. It's just that our location information will be wrong because it'll be on the pre-processed source rather than on the original source. But we have workarounds for doing this sort of thing. That is some of the stuff that it can do. Like I said, there's, as Liam said, we've got config files that you can kind of select everything and then ignore like a couple of rules. We have the ability to allow a particular rule just on like one line. So you can have that flag on everywhere, but let's say you've got some legacy code that you're like, yeah, okay, this stuff just has to stay bad for a bit. You can put some comments in and turn off like individual rules on individual lines, individual subroutines. And that way you've kind of got a bit more control and you can kind of ratchet the quality of the code up without, meaning that you have some new code, you can catch all the stuff that you want to catch and still allow it in legacy code. Cool, okay, I think that is what I want to say. Back to you.
Okay, yeah, Jeff. Cool. Yeah, so to quickly go through kind of how we got to where we are. So this project kind of started life as an in-house tool. It's something that I wrote myself because I was working on a Fortran project at the time. And what I found when I was working on it was it was code written by a former PhD student in our department who handed it over to another PhD student, and I was trying to get it all kind of cleaned up and ready for hopefully a future public release. And I just found it was completely riddled with like, it's not only errors, the code worked, but it was just like inconsistencies, just the code starting to change from one file to the next. And yeah, there was just, things like, like really inconsistent use of real kinds, and implicit none wasn't used everywhere. Some of the functions were just floating outside of modules, all this kind of stuff. So since I mostly work in Python, my first thought when I come across this kind of code is just throw Ruff at it, run with all these standard auto fixes, and there you go. That'll, well, rough and black, I guess, and there you go. It'll be instantly formatted and instantly fix most of the low-hanging fruit kind of errors like that. So I thought, well, this is up to the same thing in Fortran, and I just could not find an open source solution to that problem. There are commercial linters that will do that, but that wasn't really an option for me. Most of the things that I found in my search were these kind of just abandoned, kind of really immature hobby projects for the most part. And so I thought, well, maybe I'll make my own hobby project. Why not? Maybe I'll add one more to the pile. So when I started this problem, I immediately put on my RSE hat and just thought, let's not reinvent the wheel, let's just reuse whatever resources are already out there, best to my ability. So yeah, I'm a big fan of Ruff, as you've probably figured out by now. And so I kind of looked to that for inspiration. I think as well, if I can kind of get as close as possible to kind of mimicking at least the user interface of Ruff, then given that possibly most Fortran programmers nowadays will also be Python programmers to some degree. That would provide like an easy onboarding experience for people. If they already know to use Ruff, then I can say, hey, look at this new tool. It works exactly the same. Try it out. See if you like it. So, yeah. So the first thing I did was really just start reading Ruff. Just try to dive into their code base and just see how that works. Now, the immediate hurdle I ran into was that Ruff is written in Rust. Which is kind of why Ruff is such a high-performance kind of alternative to a lot of the other Python linters out there. So in order to be able to copy as much from Ruff as possible, then I figured, well, I guess this is what I have to learn, but of course you don't come across Rust in a research environment basically ever, so this was all quite new to me. Now, I did come from a background in C++, which was really quite helpful because that means a lot of the weirder concepts in Rust were kind of familiar to me. You can kind of map them onto similar sorts of concepts. So the issues like mutability and ownership are kind of just map nicely onto move semantics and constantness in C++ and these sorts of things. Like traits are basically like concepts if you squint at them. Some other things in Rust are still kind of pain points to me, which are something I still trying to wrap my head around. Things like you have to manually tag object lifetimes, which can get a little bit confusing at times. But, I persevered, and after using it for over a year, I honestly, once you get to grips with it, it really is a lovely language to work with. Honestly, at times it's easier to write Rust than Python, depending on the application, because it'll catch any kind of typing issues or things like that just automatically out of the box. Another advantage if you're writing a tool like this, which might be running in people's CI jobs up to thousands of times a day, is it's well, beyond being faster, it's also kind of the greener option. There was a famous paper in 2021 saying if you could have roughly the equivalent task in pure Python versus pure Rust, then Rust is something silly like 75 times more efficient. So it's something to consider if trying to decide which tool to use next. So the next big challenge in how to write a linter was how on earth do you parse Fortran? So a lot of the open source tools that I found were actually just using regex. But if you ever try that and try to do any kind of serious code analysis, you find you don't get very far with it. It'll tend to miss anything that stretches over multiple lines. It's really hard to do multi-line regex well. And like, what's the other one? Yeah, things that are in strings and comments. You have to hit the code, but not things that are meant to be commented out. And yeah, it's a nightmare. So what you really want, instead of just regex and going line by line, is to actually be able to iterate over the code in some kind of more rational sort of data structure. So you can say, like, here's my Fortran module, and now I want to iterate over all the contents and find all the functions, and then for all the functions, I want to find all the variable declarations, like that kind of thing. A lot of people who write these tools like that is the point where they get stuck, because writing a parser is really hard. I found that one already existed, it's Strata, and I knew that Peter had recently done some work improving the Fortran interface for it. So it also offers some really nice Rust bindings. So once I jumped on that, then immediately the hardest part of writing a linter was just sort of already solved for me. And so with just staring at the Ruff code and having tree setter on my belt, I just bashed out a prototype in a few days. It really was, like, once you've got a parser, it really is that easy to make these kind of tools. And I kind of started working on it through early 2024. I only really added the rules that I needed for my immediate project, because I was the only person using it, I guess. And it's these kind of rules, things like missing implicit none, like things that are really quite straightforward. And that was enough for me to get through my current project at the time. So I did all this within the span of about a month, and then promptly stopped working on the project. I just had other things to work on. A few people did discover it in this time. Actually, Jack at ICCS noticed it and thought, hey, this is pretty neat. So I think ICCS were one of the first adopters. But beyond that, yeah, the project was kind of dormant for a long time. The big impetus to kind of work on this properly was a meeting at RSCCon 2024, organised by Andrew Brown and Austin Rayner, called Back to the Fortran Future. It was kind of a workshop that brought together about 45, 50 odd Fortran developers from across the UK, well, and beyond actually, to kind of discuss what are the challenges facing the community and try to find some actionable solutions for this. And what came up with this workshop were kind of the same few problems that were being brought up over and over again. So it was things like there's not enough good training material, we don't really know what the community standards even are, and there just aren't any tools. So I think attending this was really quite inspiring for me. It really drove home that there was a genuine gap in the ecosystem here, and that the community really were looking for something to kind of fill that. Another thing is it also made it clear that there were a lot of other UK-based Fortran developers who may have an interest in contributing to these kind of projects. So throughout this conference, I kind of had a few other discussions with people, found I wasn't even the only person who was working on Fortran linters. So I was able to kind of get a better idea of what people wanted out of these tools, and also through these discussions I was able to kind of rethink my core implementation of Fortitude, which gave it a massive performance boost. I'm talking like 10, 20 times faster than it was when I'd first written it. And so at this point, I kind of demoed what I had to Peter, and Peter got on board. And then Peter kind of brought a new perspective to the project. I've been looking at Ruff as a kind of a template I can kind of like borrow ideas from. And then Peter pointed out it's MIT licensed, it's all free code. You can just take it, like there's nothing stopping you. As long as you acknowledge where you got it from, it is free use. So yeah, so from that point, we now had twice as many developers working on it, and we had this huge resource to mine for kind of new features. And every time we wanted to implement something new, we could just check how did Ruff do it. If it wasn't Python specific code, we could often just lift that code wholesale and just adapt it for our purposes. So at that point, the development pace just skyrocketed. So we now have a bunch of these kind of cutting edge features, things like a huge array of different output formats that Ruff has. We could just basically copy all of that. And with taking them insane amounts of effort to implement, it took us very little, comparatively speaking. So yeah, we could even go further than that. We even just look at their entire workflow. So we could copy like how are they doing their tests? Cool, we'll just use their testing setup. How are they doing their kind of CI jobs? We can just use that too. So that has really accelerated the pace of development. And so shortly after Peter joined and the pace started picking up, we were kind of discovered by users on the Fortran Lang discourse group. There was a thread there where people started discussing it and providing quite a lot of criticism, actually, which was kind of helpful. We had been planning to get a few more features in before going public with it and trying to get a user base, but once it happened, we thought, fine, we'll just roll with it. So we started advertising our releases on the RSC Slack channel and also on those forums. And since then, we've seen very rapid user growth. So if you look at the graph on the right, this is our GitHub start history. I'm not sure how accurate that is as a estimate for how many users that we have. But so ours is the red line right on the right-hand side there. You can see it kind of being quite small and plateauing for the 9-ish months that I'd made it and sat on it and didn't do anything. And then it's just shot up ever since, and it's overtaken most competitors. We're catching up to Camfort, just about. And while this user growth has been happening, we've also been seeing more contributor growth. So Ian at Imperial College I'm very grateful to him because he found the project, was able to figure out how it worked, and has contributed, I think, 5 or 6 different rules, I believe, something like that, and he's been actively contributing to all of our discussions, which is very, very helpful. And so looking forward, we currently have 65 linting rules implemented, no, 67, I think, last count. We've already identified a list of well over 100, about 150-ish, I think, that we would like to get in there eventually. So one thing Ruff offers that we don't is a formatting mode. We really want to get this in. We have made some steps towards that. Peter's done some, and Tom, huge thanks for that. We are looking at the CPU processor. We've kind of already got a plan for how we're going to do that. We just have to find the time to do it. Hopefully we should have that before the end of summer. Peter's also looking at implementing language server protocol, so you can hopefully have this running in the background in VS Code or NeoVim or whatever you're using. And beyond that, we already have plans to kind of upgrade some of our internals so we could also get more semantic info in the rules, so hopefully to give even more powerful sort of feedback on how to make your code better. Right, there's not a whole lot of time left. But Peter, would you like to have a quick chat about parsers?
I'll quickly give an overview of parsers. Right, as Liam was saying, regular expressions. Everybody reaches for them first when they're making a hobby project, because I imagine most people here kind of use regular expressions fairly regularly, if not every day. And so you're looking for patterns in code. Patterns in code means regular expressions. However, I mean, they've got a reputation for being right only. Anybody tell me what that regular expression does? Like, I think it's probably the worst way that you could write that one, but it's also, that's difficult to work out. You can sit there and work it out, but you also need more structure than just regular expressions anyway, because if you want, a list of all the intrinsic types in Fortran, probably more than one rule wants to have those types, and you don't want to have, be putting those in literally every regex, so you need a bit more structure to inject things like that. And also it can be performance limiting, because for every rule, you need to start from the top of the file and scan through every byte, checking for your regular expression. Does it match at this byte? Does it match at the next byte? It's quite easy to destroy your performance in regular expressions by using things like back references. So interestingly, the Rust standard library regular expression module doesn't let you do things like back references because they're like, there isn't a fast way to implement this, so we don't. And also Fortran has things like non-reserved keywords. So this is valid Fortran. And I mean, like, you laugh that people would write stuff like this, but genuinely people write stuff like, I mean, not as bad as this, but like using if as a variable name, people use that. Because they go I, ij, ik, and and go through the alphabet and they get to if as an index or something. And as I found, almost every other keyword in Fortran appears as it's somewhere in that 40 million lines of code that I've got. So we use, so the next thing we actually want to use is abstract syntax trees. So trees are a kind of data structure. If you don't know that, they look like this, or if you write them in a kind of lispy way, which is a popular way of writing trees or displaying trees, they look like this. So for an assignment statement like this, the top level thing is the statement. The statement is made up of the left-hand side, which is an identifier. In this case, right-hand side, which is a math expression, you can tell in American with this. And the math expression is made up of an identifier operator and a number in this case. And so the grammar, hang on. So, yada, yada, yada. The thing about ASPs is they do miss semantic information. So Fortran has ambiguous things like, if just as looking at that, is that a function call or is it an array index?
You don't know until you've got the type. So the AST misses that out. This is just, in the Fortran grammar that we've got, this is just stored as chord expression, something like that. And we don't have that information in Fortitude yet to be able to tell if that's a function call or an array index. You would need to do things like possibly parse the whole project, construct what type every variable is and how it's used and passed into the function. So that's actually quite a bit more effort. The theory part, you can get into the theory of parsers, but we don't actually care. We just wanted something that worked. And although there are a bunch of parsers out there for Fortran, they're either like unmaintained or I'm very lazy and it had more than one step to install it. And I was like, that's not happening. The thing about, and we would like to maybe use like compilers directly because, presumably they can parse everything correctly. So I would like to use that, but until very recently, G-Fortran was really the only open source option. And if anybody's looked at the internals of G-Fortran, you're not using that to build on top of it. Not Flang is now an option, but they don't have a stable API, and building the parser separately from the rest of building Flang, nightmare. And L-Fortran also an option, and I've kicked their CMake to the point where you can now build the parser separately, but they make some interesting choices. And maybe we'll use them at some point, but for now we're using TreeSitter. So as Liam explained, TreeSitter is a framework for making grammars. It's not a parser itself, it's a thing that makes parsers. And so there's a ton of grammars for different languages out there, and TreeSitter is like a framework and a library that lets you use those in a consistent way. So you might see lots of editors now have a TreeSitter mode for like highlighting. It's stupidly fast for parsing, so it's quite error tolerant. So for like syntax highlighting your code, it doesn't fall over just because you're in the middle of typing the word integer, and it can highlight your code much faster than regular expressions. So people are using things like that. And the neat thing is that it takes your grammar and turns it into a single C file. It's maybe like 500,000 lines long, but it's just like one big state machine, 0 external dependencies. So it's just a C file that you can compile into a shared library, which makes it trivial to compile on any machine and wrap up with like Python bindings or Rust bindings. And so this makes it super easy to just integrate into a project. So if you've got something where you need a parser, and not necessarily Fortran, I mean, TreeSitter might be a good option to be like, hang on, I need a parser quickly to parse my input files for this project or whatever. I might suggest that. So I won't go through all of this, but this is what TreeSitter grammar looks like. So assignment statement, this is like a weird JavaScript subset. So it's JavaScript, but it doesn't get executed as JavaScript. It gets passed by Rust and turned into C. That's just how it is. So this is an anonymous function with an argument $. So assignment statement is a sequence of an expression, equal sign, and another expression. An expression is a choice of number literal, identifier, or a math expression. A number literal is this isn't actually how it is in the Fortran one. This is just slideware. This is some numbers, some digits. An identifier is something that starts with a letter and has some other word stuff. And a math expression is, I'm not going to get time to talk about left and right associativeness, but basically it's a sequence of an expression and one of the operators and another expression. And that's like a fully complete grammar for these sorts of statements. So I'm going to skip those. Interesting, but not super relevant. This is some Python for how you walk it. Here's some actual Fortitude Rust rules. So some interesting things to point out. We're using, so this is, again, stolen from Ruff. This is a Ruff proc macro. So this is Rust can use these proc macros and it takes a syntax stream, like an AST of your code, and can do stuff to it. So this macro just knows that there's a comment here, grabs this comment, puts it into another data structure, and we can dump that to file. So our website, the docs on our website are generated from comments in the code, just from like a little macro like that. And again, because it's working on the AST of the Rust code, it knows what types things are. And the last bit, some Rust. Again, I don't really have time to go into it. Yeah, that's basically it. Right, so, I should say, full disclosure, treats it to the bad parts. When it goes wrong, it's wrong. Like, that's it. You just, it's not working. Like, why have you failed to pass this? Well, so, and then debugging the grammar to work out, how do I change the grammar to make this work? Absolute nightmare. But when it works, it's lovely. Right. Okay, to sum up, use Fortitude, it's great. Use Rust, that's also great. Use Tree Sitter, that's also great. And use ASTs, they're also great. Thanks.
Brilliant. Thank you very much, both of you. We are about to time, so if people need to head off, don't worry. But otherwise, we've got a little bit for some questions. If anyone has any, please do ask. Joe?
Fixed mode is working, and you mentioned that forward mode format mode is coming. What's the difference between fixed mode and format mode?
So the check mode is we've got rules that are like obsolescent features that we want to catch, correctness things, bug-prone issues, and style things that we think you should fix. The format mode will be much more opinionated. The first implementation is going to be very opinionated, and it will do things like indentation, sorting out white space, stuff like that, and applies some of the style rules. So some of the style rules will overlap with the format mode, but you probably only want to use one or the other because they overlap.
Yeah, so the aim for format mode is kind of like f-prettify is kind of what we're probably going to use as like a standard to kind of match if you've used that before. So yeah, so it's just white space and stuff.
But do you see it growing big in other ways just the linter, because the grammar you can, for example, the tools to generate the call graphs or whatever variable is used.
So yeah, you could do all that. We don't do that currently in Fortitude, but yeah, we could do that. But like I said, you might need to pass the whole project to get the module stuff. So that requires a bit. So I'm the maintainer of Ford, which is Fortran documenter, and it does things like that. And it's not difficult necessarily. It just takes a bunch of effort to implement and do. But yeah, we could do that.
Yeah. There's some questions from Dominic. Can you handle non-context free bits of Fortran like coalesced end do's?
Yep.
Do you support DEC extensions, or is it possible to extend?
So if it's not in the grammar, no, but the grammar does have some extensions. So I think, for example, like $signs in identifiers, like not part of the Fortran standard, but it turns out enough people use them that I added them to the grammar, and explicitly so I could write a rule, which I haven't done yet, to say don't do that. But yeah, so things like deck extensions, we might, if there's demand, we can look at getting them in there.
Any other questions?
Have you thought about domain-specific rules, linting rules? For example, say you have F-torch and you want to add some specific linting rules for that package. Have you thought about how much to do that?
Yeah, so one thing, so we want to implement rules from other linters. And so, for instance, Castep, they've got a linter, also using Tree Sitter, in fact, to catch some Castep specific things, some of which I think we can just use straight away. And Stylist as well has like some rules which are like, don't use this module,
and it's like hard-coded what that module is. And I think we can implement that as like a rule for like, have an option of like mark these modules or functions as deprecated. And then if it's empty, that rule doesn't do anything. But, the user can add what they want and we'll catch those. But also, yeah, maybe there are some like more project specific things. I think we could get them in and it would have like a category of that thing.
So we can cast that people, say the domain specific people, they have to rebuild Fortitude because they've added their own rules. So it's like for Fortitude, you kind of.
So Ruff currently sort of has this similar thing, and they just implement it in Ruff. It's the same for Clang Tidy for C++. If you want your own rules, you either have to compile it yourself or you have to get it into the main thing. So if you look at Clang Tidy, there's a whole bunch of like Google or Microsoft specific rules because they're big enough they can just get it, do the work and get it into Clang Tidy. We're certainly not opposed to looking at getting some project specific stuff in there. Plugins are also an option where you'd have compiled dynamic library and then dynamically load it. I don't know how we would do that exactly, but Rust tends not to have a stable ABI, so that you might end up needing to, we release a new version, you need to recompile your plugin, say. So it's a challenge, but it's not insurmountable.
Just to finish off, I just mentioned there's a tool called HLint, which is a Haskell linter, which we also developed at the University of York. And they let you write linting rules in the concrete syntax of Haskell itself.
Right.
So you can that provides a mechanism for why specific people can have their own sets of rules.
So the other option is there's a tool called AST grep, which uses treesitter for being able to grep the AST, surprisingly, of your code, and they've got like a language that you can describe in like YAML or something, so you can describe your own rule, what you're looking to catch in some kind of high-level language in their past. So that would also be an option that we could provide. I mean, we could just steal that, like what they do, and let incorporate that. The downside of that is one of the ways that we get that kind of level of performance is by not searching for the individual rules at a time. So we walk the AST and we've got like a mapping of this rule. Where has it gone? So here, this rule has these entry points vector. So on keyword statements, so we're walking the AST, and every time we see a keyword statement, we run this rule. Rather than we run this rule by walking the whole AST looking for keyword statements, and then we run the next rule, yada, yada, yada. So this way you get, what did you say, like factor 20 speed up? Yeah. But that would be the compromise of being able to have runtime described rules.
I have one last one from Dominic, which is, can you catch non-local issues like induction of variables and reverse order for column looping? By which I think he means looping,
yeah.
do I, do j, do k versus do kji.
I think in theory we could do that. I can't see it would take a bit more effort because that isn't the kind of thing that would just pop out of treesitter. But yeah, nothing is in theory.
Yeah, I think like you look at an expression, you see that it's being indexed ijk, and then you look at the loops and you go, oh wait, these are in the wrong order. It's totally possible. The devil is in getting that refined enough that we don't get false positives, because we don't want people to run Fortitude and be like, well, that's wrong. That's not a good experience for the users. So if we can, I would look like that. That's a really great example of something that I would love to get into Fortitude. It's just you got to really think about how do you catch that in a generic way. Yeah.
I was just going to comment on that very quickly. It starts to sound a bit like Cyclone. You're aware of Cyclone? That does sort of transformations and stuff like that. That's the kind of thing that they do. So.
I'm aware of it, but I've not actually looked into it that much. Sorry.
I'm happy to chat about it as well.
I'm saying, think that sounds like, let's go and get a coffee. But thank you everyone for coming, and thank you everyone online. We will be around those in person for the next hour or so do come and chat if you want. Otherwise, we just thank the speakers once more. Thank you very much.